Okay, boys and girls. So to solve equations, we're going to have to do inverse operations. Who knows another way of saying inverse operations, an easier way, and not real mathy way? Kasaya? Kasaya? Good, opposite operations. So we're just going to do the opposite. So to solve an equation, do the opposite, or use inverse operations. And this should just be a review for you guys. This is an easy one. 10 plus n equals 18. And you always do the opposite of what's in front. So what's in front of that 10? What's in front of it?
The
You gotta talk loud. What's in front of 10? There's no 1 in front of 10. What's in front of 10 right there? Nothing's there, right? So we assume that if nothing, that it's a positive or negative.
positive.
So we got to do the opposite of positive and subtract it. So minus 10, minus 10. That cancels out, so you're left with n equals 8. And how can we be sure that that really is the right answer? How are we going to know for sure? Taylor? Go replace it, check it. So over here, we're going to perform a check. So 10 plus n equals 18. But n is no longer n. It's not n anymore. Is it, Martin? What is it now? We just solved it. What does n equal? We just found it. 8. So now it's 10 plus 8 equals 18. 10 plus 8 is 18. Does it balance? Check. It works out. Nope, we're recording. All right, how's this one different from the last problem we did? The last one was addition, subtraction. This one is, so we still have to do the opposite though. So what's opposite multiply? Division. Nice and loud. That's what I like to hear. Divide by 8. Divide by 8. So x equals 4. I forgot to circle my last answer. We should have done that. You guys should have yelled at me. Ryan, how can we be sure this is right? What should we do? Good, check it. I'm going to check it over here, so I'm going to put 8x equals 32, but it's not x anymore, it's 4. Does 32 equal 32? We are good. Nice work. Go team. Now, how's getting dressed in the morning different from when you go home and get undressed and ready for bed? How are the two different from each other? What do you think?
Is it the clothes or is that?
Everything, the whole, like, let's just look at our feet for example. How are your feet in the morning when you're your feet ready for the day different than when you get home?
You take something off, but you put something on? I don't know.
Sorta, kinda. I think you're missing the point a little bit though, but you're on the right track. They're the opposite. Like when you get your feet ready for the day, what do you put on your feet first? And then, but at the end of the day, do you take your socks off first? You have to take off your
Shoes.
you gotta take off your shoes first. This is kind of the same thing with two-step equations. So we actually solve a problem. What do you use to help you solve it in the right order? Dallas, what do you use to solve a problem in the right order? Your dear Aunt Sally. So that's kind of, your dear Aunt Sally is kind of like solving the problem. It's kind of like putting your shoes on in the morning. But when you come home, you have to do everything opposite, backwards. So that's how you're going to solve two-step equations backwards. So you're going to have to do your dear Aunt Sally reverse, backwards.
She's gonna be on her head?
She's going to be standing on her head, yes. So it's going to be Sally, Aunt, dear, my, please, something like that. So when you solve a two-step equation, you have to undo or do the inverse operation. I always mess up. Farthest, furthest. I think it's supposed to be furthest, isn't it? Not farthest.
Yes.
Make that a U. Variable. First, so you have to undo the furthest thing away first. You can think of it like dear Aunt Sally backwards. And when I say furthest thing away from the variable first, I kind of assume that you know what I mean by it being the furthest thing on the same side of the equal sign. So I don't mean this 20. What's the furthest thing away from the variable, away from the y in this particular example problem? Harry?
The 7?
The 7. So guess what we've got to take out first?
7.
The 7. That's like taking our shoes off before we can take our socks off. So we have to undo the 7 by the opposite adding. Whatever you do to one side, you do to the other. So that will cancel out. We get 3y equals 27. Now what should we do, Kyle? We just have a new problem. 3y equals 27. So how will we solve that? We have to get y by itself by doing the opposite. So what do we have to do? Good. And this means 3 times. So what's the inverse? What's the opposite of times? Division. So we would divide both sides by 3. So y would equal 9. Then if we want to check that, be 3, it's not y anymore, it's 9. 3 times 9 minus 7 equals 20. Now this is like getting ready in the morning. Now what will we do first, Lindsay? And this, when we plug the 9 back in, what are we going to do first this time around? Take a guess. What do you think we would do? If you just saw this problem right here, what would you do first? Would you add, multiply, subtract, divide? Multiply the 3 and 9, good. So it's 27 minus 7 equals 20. And subtract the 2. Does 20 equal 20? So it worked out. It checks out. We're good.